Little reminder, first of all, area is the space inside a two-dimensional object. However, on a three-dimensional object, you have different surfaces, different edges, different sides. And for each surface, you can calculate the surface area. Once you have each area, you can add them up to get the total surface area. Often we abbreviate it TSA for total surface area. You know what surface area really is? How much wrapping paper you would need to cover up a three-dimensional object. That's really what we're talking about. So with each figure today, you need to ask a couple of questions. How many sides are there? Are any of them identical so that instead of finding each one, you can just multiply by 2 or by 3 or by 4 to add them up? What's the shape of each side? What's the dimension of each side? As an example, a rectangular-based prism. How many sides are there of a rectangular-based prism, grand total? Count them. 6. And each side is a rectangle. So each of those sides will have an area. What was the equation? What was the formula for the area of a rectangle?
Area equals length times width.
Okay. Length times width of that particular side. It may end up being a height depending on how that side is pointing, what the orientation of that side is. In fact, you can say that the surface area is, what's the area of the top side? As an equation, what's the area of this? Let's write down here LW. What's the area of the bottom? What's the area down here? Also LW. What's the area of the front side? This guy right here. LH, right? And what's the area of the back side away from us? Also LH. And what's the area of the left and the right sides? Each one of those is HW. And you'll notice we can gather some like terms. How many, the short version of this, how many LWs are there actually? Let's go 2 LW plus, how many LHs are there? 2 LH plus 2, how many HWs are there? Is that what it says on your formula sheet? No. Go look. Find a rectangular prism. Not exactly. Okay, it has this line. Yes? But they didn't quite write it this way. How did they write their equation? Yeah?
They wrote that WH plus LW plus LH all in brackets times 2.
They GCF'd, which is nice review of factoring also. I don't mind that. They GCF'd. They said, you know what? You can either go 2 times, 2 times, 2 times, or you can just factor out the 2 and multiply by 2 at the end. Do what's inside the brackets first. Equally valid both ways. Okay? What about a triangular-based prism? Well, how many sides does this shape have?
5.
1, 2 from behind, 3, 4, has 5 sides. Now, Jordan, I think what you did is you unfolded the shape in your mind. When you unfold the shape in your mind, there's a fancy word for that. We call that a net. If you cut it apart and lay it all flat and visualize each side. 2 of the sides, what shape are 2 of the sides? Triangles, the front and back. And that has a formula, an area of base times height divided by 2, right from your formula sheet. What shape are the other 3 sides? So the other 3 sides are rectangles with a formula of LW. So the basic approach, Brody, to any surface area is find the area of each side and add them all up. Oh, and Kira, if you're lucky, you might spot a shortcut, like we did in the previous one where we noticed we had pairs of sides, pairs of sides, pairs of sides. But when in doubt, Amber, carefully visualize each side, find its area, add them all up, and you'll never go wrong. That's the actual one-size-fits-all surface area equation. Okay? Here, I think we would have this. Let's see. The front triangle, the base is that long. We called that L. The height is that long. We called it W divided by 2. That's the area of the front. The back, Anthony, is the same shape. What's the area of this big flat panel here? What shape is it, first of all?
Rectangle.
Rectangle. So what times what? Based on the letters that I've used in my diagram.
B and H.
BH. What's the area of this back shape that we can't see, that side shape there? It's a rectangle.
HBH.
Let's see. That times, I think, AH, yes? And what's the surface area of the floor? Anthony, you're right. LH. And if I had numbers now, I would just go to my calculator. Okay. Sometimes what they'll love to do, look up, they'll love to give you, I'm going to erase some of this, a right angle right there. They'll give you that. They'll give you that, and they'll make you use Pythagoras to find that. That's sure, fair game. Nice review question. They didn't in this question. What about a square-based pyramid? How many sides?
5.
5 sides. What shape is the floor? Square. And what's the formula for the area of a square? Well, a square is a rectangle. Every rectangle is length times width, but if your length and your width are the same, you can just think to yourself L squared or width squared, or sometimes they'll call it S for side squared. I don't like using S because my S's all look like what number? 5. 2? Really? My S, really? That's my S at 5. Mr. Rocca's class is going to be watching this video next class, and everyone's going to wonder, who the heck said that? I won't say their name. They'll find out through the grapevine. Hey, the other 4 sides, what shape are they? Triangles? The other 4 sides are triangles. Learn to write, Mr. Dueck. Area of a triangle is base times height divided by 2. So this particular shape here, using the letters that they gave you here, what's the surface area? What's the surface area of the floor? So it's going to be b squared plus, what's the area of this triangle here? Well, it's base times height divided by 2. And then another one, this front triangle here is base times height divided by 2. Slant. It's often used for a slanty side. Slant length. It's a good question. The question was, why is the height an S? By the way, it doesn't matter what letters we use. I just got to be able to recognize what I mean by height. What I mean by height is the distance from the middle of the side, dead center, to the tippy point. Oh, and Darian, I've also on the provincial seen them give people a right angle triangle like that where you have this number here and that number there, and you have to use Pythagoras to find the slanty side. Yeah, sure. Bring it on. I can do that. Another triangle, or you know what, really it's b squared plus 4 times base times slanty height divided by 2 because there's 4 of them. Really, let's start doing some with numbers. It says, find the total surface area of each of the following. A. What shape? Okay, and you know what? It's a rectangular prism. It's going to be 6 sides. It's going to be 3 pairs of 2. It's going to be the front side times 2, the floor times 2, or the ceiling times 2, and then the left side or the right side times 2. SA equals, what's the area of the front side? What times what? What's the area of the front side? What times what?
15.
It's going to be 15 times 5, and there's 2 of them, front and back. Is that okay, Jordan?
Mm-hmm.
Plus, let's do the floor and ceiling. What's the area of the floor? How would I calculate it? 15 times 4. And there's 2 of them. Plus, what's the area of the right-hand side there? And how many of those are there? 2 of them. What if they cut one of those off somehow? Like, what, for example, what if it was a box with no lid? Oh, subtract one of the ceilings or floors. You can work your way there. What do you get? It's going to be 150 plus 120 plus 40, I think. 150 and 120 is 270 plus 40. Check, is it 310? Double check me. Am I wrong? You got what? Am I wrong? I could be. 2 times 15 times 5 plus 2 times 15 times 4 plus 2 times 5 times 4. 310. I did it in my head, people. 310 what? What are the units? Not millimeters. Why millimeters squared? What did we just find? A surface what? Area squarea. Area is always squared. Volume is cubed. Area squared. Length or width, no exponent. Okay? B looks kind of cool, but actually I want to do C. So I'm going to skip B. B and C are similar shapes. Let's plan our attack here. Can you visualize the net of C? Can you visualize each shape that this is made up of? Tell me what they are, Greg. More specific. How many triangles? You know what? Let's plan our attack. This is worth jotting down. Let's recognize there's going to be 2. Good gosh, Mr. Dueck. Is that a good abbreviation for 2 triangles? And are any of the, how many rectangles are there? Are any of them the same? Identical? Okay, so I'm going to go like this. Rectangle 1 plus rectangle 2 plus rectangle what? 3. Okay. That takes 1 second, and that gives us our plan of attack. There is no generic formula for this. It's visualize each shape, visualize the net, visualize this all unfolded and laid flat. Okay. Now a triangle is going to be base times height divided by 2. Plus, you know what, Brody? Let's go like this. How about we point an arrow? We'll call that one rectangle 1. We'll call this one rectangle 2. And we'll call this one rectangle 3. That takes 1 second, and now I'm organized. And it's going to be length times width, length times width, length times width. But these are all different lengths and widths. So don't think, oh, I can gather like terms. That's 3 length W's. It's not. fact, let's call it length 1, width 1, length 2, width 2, length 3, width 3. There, now they look different. You okay with this so far, Alon? Yeah? Let's start plugging in numbers, shall we? Equals. See the triangle facing us. What's the base? How long? 12? What's the height? How high? What's the relationship between the base and the height always? What angle is always between them? It's got to be a 90-degree angle for it to be a base and a height, okay? That's what you look for. 9 divided by 2 plus. Okay, rectangle 1, what's the length, what's the width?
9 and 3.
Rectangle 2, what's the length, what's the width? That's the floor. 12 and 3. Rectangle 3, what's the length, what's the width? Problem. Well, I got the width okay. What's the width of rectangle 3? What's the length? That. Did they tell me that? I must be able to figure it out. Brody's nodding. How? Oh, you're saying it's also this? And I can go Pythagoras? Yeah? So over here, what squared plus what squared equals what squared? I'll call it c squared because it's a hypotenuse. What do you get? What does c squared work out to be?
15.
What does c squared work out to be? 225? Yeah? And then Jordan already said, hey, square root, what's c?
15.
15? So it's going to be 15. There. Now I can get the surface area. Carefully try that on your calculator. You can try doing it all in one step, or you can do it in separate chunks if you want. I think it's going to be 54 plus 27 plus 36 plus 45. 12 times 9 divided by 2 plus 9 times 3 plus 12 times 3 plus 15 times 3. Yep.
I think you're missing a triangle.
You think I'm missing a triangle? Why am I missing a triangle? Alex? Nobody said anything. Where am I missing a triangle? Ah, what did I write right here in front?
2 triangles.
So put a 2 right there. Put a 2 right there. And make that 108. Are they identical triangles? I can do that, yes? Nice. I was waiting for somebody. I was waiting for somebody. Nobody said a thing. Okay. Alex, candy for you later. So you're saying it's really that? Put a 2 in front? So you're saying the answer is 11,475? Oh, I got a times in here when I shouldn't. Mr. Dueck, let's go see. Fix your typing. 2 times 9 times 12 divided by 2 plus 9 times 3 plus 9 times plus 12 times 3. Ah, the plus sign didn't come in. How about you get 216?
Yeah.
Woohoo! Units.
Meters squared.
Okay. What's the formula for surface area? Hey, find the area of each side and look for shortcuts, Amy. D. D. I think that this is going to be, it's going to be what? Visualize the net, visualize this unfolded. What does it look like? What do you see? I think it looks like this, right? There'd be this. If you were to lay this flat, the net would look something like that, would it not? So I'm seeing a rectangle. In fact, a square, I think, plus 4 triangles. All right. What's the area of a square or a rectangle? Length times width plus, we won't forget the 4 this time along. What's the area of a triangle?
BH over 2.
Base times height divided by 2. Okay. What's the length of this rectangle? 18. What's the width?
18.
Also 18. You know what? Is that a shorter way to write that? Put a little squared there. Plus 4. Now, here's the triangle we're talking about. What's the base? 18. What's the height? 14. Don't forget to divide by 2 because it's a triangle. What is 18 squared plus 4 times 18 times 14 divided by 2? And you need to practice this on your calculator. Do you get 828?
Yep.
800. Come on, pen. 828 units.
Meter squared.
Meters squared. Okay. It says a warehouse has dimensions 80 meters by 60 meters by 8 meters. If a painter needed to paint the warehouse, what area would he need to paint? He's not painting the floor. In feet squared. Yeah, we'll try this one. Trying to get through 2 lessons today. We'll see. I think so. What shape is a warehouse? What shape are rooms? Pardon me? What's the fancy schmancy word? Rectangular prism. Okay? And conveniently, I do have an equation for that. The surface area of a rectangular prism is going to be 2L2, Mr. Dueck. Now you got me doing an S instead of a 2. Nice one. 2LW plus 2WH plus 2, which one have I missed? LH. I didn't go in the same order as them, but I just know I got to have an L, a W, an L and an H, and a W and an H combined. Why is this wrong for this question? Anthony. Okay, let's make the floor length and width, so let's say only one floor. In fact, let's kind of visualize, I think, Anthony, something. This is about as close as you'll ever see to getting me to draw something, because I suck at this. Kind of like that, where, which of these do you think is the height? I think the 8, because 8 meters high, that's 2 stories. Now, I kind of have to guess. On the provincial, they'll give you a picture. And this is 160. This is 80. Is that all right? So what's the surface area going to be? Ceiling. Front and back walls. Two side walls. Yeah? 160 times 80 plus 2 times 160 times 8 plus 2 times 8 times 80. Is that okay, Amber? Yeah? I think. What do we get? What do we get?
60,000
16,640? We're good? Units? Well, that's square meters. Could we convert that to square feet? Do we have a conversion factor? Yes. We would go times, I want meters squared on the bottom, I want feet squared on the top. What's the conversion factor between feet and meters? Please tell me we have one. I think we do.
Yeah. 1 foot equals 0.3048 meters.
Now that's for feet and meters. This is for feet squared and meters squared. What do I do now?
Square. The one ends up 0.304.
Add a squared, add a squared. Not that it makes a difference on the one squared, but I'll put it there for symmetry. Yeah, you know what? It's going to be this number times 1. Didn't really need to do that. Divided by 0.3048 squared. Try that on you need to know how your exponents work on your calculator, so make sure you try this. What is 16,640 divided by 0.3048 squared? Yeah. What's what number? There's a bunch of 2's.
160.
One right here. This right here, that's a 160 as well, because we're going. Is that better? Of course, you could always just sit at the front, little miss. I'm going to sit in the back row corner, by choice. Saying. Do you all get 179,111 square feet?
Yes.
I'm just going to write 179,000. Is that okay, Kira? Are you trying it? Ah. Why did we square it? Because we're doing meters squared and feet squared. What if it was meters cubed and feet cubed? Then instead of squaring the conversion factor, we cube it, which is pretty easy to remember. Can you turn to lesson 5? Continuing on. Still more. I know, it's a long lesson. Humor me. Suck it up. Okay. What was that? 179,000. 111.4693. Good? Good. All right. So we've looked at pyramids and prisms. What about cylinders, cones, and spheres? Hey, you might want to find those on your formula sheet. Remember, the surface area of a three-dimensional figure is just the sum, the total, the added up of all the sides added together. Add up the areas of each side. When you have curvy shapes, visualizing what those sides are, a little trickier. So take a look at a cylinder. A cylinder is made up of 3 surfaces. What shape are the top and bottom? Circles. And what's the equation for the area of a circle? It's on your sheet.
Pi r squared.
Pi r squared. What shape is the side of a cylinder? Well, if you take a cylinder, look up. If you take a cylinder, watch this thoroughly. If you take a cylinder and you cut it along the side, what shape does it turn into when you lay it flat? Huh? A rectangle. A rectangle with a height of h, the height. What's this? What's the width of that rectangle? Careful. Close. Begins with the letter C. It's the circumference of a circle. Nice. You see it? So, the side has the formula. Now, it is going to be length times width because it's a rectangle. The width is the height. The length, Kira said, was the circumference of a circle, which I think is conveniently on your formula sheet too. What's the circumference of a circle? Find it. Find the circle. 2 pi r, or pi times diameter. In this picture, they gave us r. So what does that mean? You want the formula for the surface area of a cylinder? It's 2 pi r squareds, 2 circles, plus 1 rectangle, but that rectangle has the length of 2 pi r and the width of h. It's 2 pi r squared plus 2 pi r h. It almost sort of rhymes, but not quite. Double check on your formula sheet. Is that what they have written there for surface area? Find it.
Yes.
In fact, what do they have written right above it? They've told you the area of the side. There it is, the 2 pi r h. Okay? Is that okay, Kira? Thumbs up. What about a cone? Well, a cone is made up of 2 surfaces. What's the bottom?
Circle?
Yep. What's the area of that? Pi r squared. Now, the side shape, by the way, the net of a cone looks kind of like this. You have a circle, and then you have kind of sort of a shape, sort of kind of like that if you were to cut the side and lay it flat. If you ever tried unrolling a cone, that's what it'll look like. What's the area of that? Hey, find it on your formulas sheet.
Pi rs.
Pi r s, where s is what? Anthony? No, Darian? No, it was Anthony who asked me, I think. No, it was Darian? What does the letter S stand for? Slant height. Can you see it there in the picture?
Yeah.
There's the height. There's the radius. There. Oh, and ooh, can you see this is also potentially a job for Pythagoras? See it, see it, see it, see it, see it? So you want the surface area of a cone? Pi r squared, pi r s. The weird one that you really need calculus to derive is the surface area of a sphere. What is the surface area of a sphere from your formula sheet? The surface area of a sphere? 4 pi r squared if you know the radius, or pi times the diameter squared. I like this one because, look up. What's that? What is that? Area of what? Guys, stop talking back there, please.
The area of a circle.
Turns out if you take a cylinder and you cut it up into small pieces, really small, and you lay them all flat, they'll fill exactly 4 circles of the same radius as that cylinder. Why? Take calculus. Oh, a sphere, by the way, is made up of 1 surface, right? So Garrett, you have to memorize these. I've tried to show you where they are on your sheet. Yes? Oh, hemisphere. That's made up of 2 surfaces. What's the bottom shape? No, the bottom shape. This. Not a sphere. I got to be fussy. Half a sphere. Oh, you mean 4 pi r squared divided by 2? Yeah. 4 pi r squared divided by 2, which actually just ends up being 2 pi r squared, because 4 divided by 2 is 2. What's the top? Circle. What's its area? Area of a circle. Area of a circle.
R
pi r squared. So this is kind of cool. The bottom is 2 pi r squareds, half of a sphere. The top is 1 pi r squared. Ah! Those are like terms. Ah! I can gather them. What is 2 pi r squared plus 1 pi r squared?
3 pi r squared.
I don't memorize this. I just think it's nerdily cool. What I do is I know that a hemisphere is half a sphere plus a circle. I know that. So let's try some of these. Okay. Example 1 says, find the surface area of the following. What shape? Cylinder. Find the cylinder formula on your formula sheet, and I think you'll see it says this. SA equals 2 pi r squared plus 2 pi r h. Let's see if we have all the data we need. Sometimes we need to calculate some stuff, Amy, but let's see. 2 times pi. What's r? Careful. 9 plus 2 times pi times 9. What's h? 21. You know what? This is straight calculator, plug and chug. I get 1696.5, I think. 2 times pi times r squared plus 2 times pi times 9 times 21. And that's area, so it's millimeters squared. Psst. He's throwing you under the bus. Is that okay? B. Hey, what's this? Cone. Find it.
Pi r squared plus pi rs.
Do I know R?
Yes.
10. Do I know S? Oh, I love, did you hear him? He didn't say no, he said not yet. Because S is that there. Not a 2. S is that there. Oh, I can go Pythagoras, can't I? S squared is going to be 24 squared plus 10 squared because it's a hypotenuse. By the way, Anthony, they could also have given you this and made you find the radius. If they didn't tell you that, you'd have to subtract using Pythagoras because they gave you the hypotenuse. That would be fair game. Uh, 24 squared plus 10 squared equals 676 square root. Woohoo! S equals 26. Let's even label that on my diagram. And now, Alon, I'm good to go. Pi times 10 squared plus pi times 10 times 26. I get 1131. Meters squared. Square meters. Pick it up. please. Put it away. Is that all right? I know I've been talking a lot. Stay with me. C. What's the surface area of a sphere? 4 pi r squared, not cubed, squared. So volume is 4/3 pi r cubed. Surface area is 4 pi r squared. 4 times pi. Careful, what's the radius? Don't say 13.
7.5.
Don't say 7.5. 6.5. Ooh, boy. 4 pi 6.5 squared. 530.9 square meters. What shape is D? You know what? That's going to be sphere divided by 2 plus 1 circle. I want to get to some weird funky shapes, so I really want to skip D, and what I want to do is jump down to example 2 here. A composite shape. A composite shape. It says, find the surface area of the following figure. What is this made up of? Pardon me? Okay, its volume would be cylinder and hemispheres, but now I want you to think, Ty, what are the external sides? First of all, how many different sides does this thing have? I think just 3. Right? The round middle and the 2 ends. Ooh, the 2 ends, can you imagine I can smoosh them together? If I did that, what would the 2 ends form? Okay, I'm going to say that this is actually 1 sphere plus, it's not a cylinder, not the surface area of a cylinder, because the surface area of the cylinder included the 2 end points, but are the end points of the cylinder exposed? No, so it's just the side of a cylinder. Yes? Which is a rectangle, but ooh, did they give me the area for the side of the equation for the side of a cylinder somewhere in my cylinder surface area? Okay, let's try and write out an equation. First of all, 1 sphere. What was a sphere? Equation-wise, what was the equation for the surface area of a sphere? 4 pi r squared plus, and what was the equation for the area of the side of a cylinder?
2 pi r h.
All right. 4 pi. What's the radius? Careful. Ah, thank you. Squared plus 2 pi. What's the radius? 5. What's the height? Not 10. Got it right? Think the cylinder is laying flat. The height is actually that 12. Surface area of this composite shape? 4 times pi times 5 squared plus 2 times pi times 5 times 12. 691.2.15. So, Brianna, if they give you a composite shape, don't freak out. Just visualize the net. Visualize the sides laid flat. Hey, it's a cylinder and a rectangle. Sorry, a sphere joined together and a rectangle. And don't include as your surface area any sides that are actually not exposed. Yep.
Wouldn't it be millimeters squared?
Thank you. Millimeters squared. Sheesh. Candy for you too. What's your homework? First of all, from this assignment. Okay? You got 15 minutes. Quit your whining. You got lots of time. You can do 1A. You can do 1C. G. And H. What about here? L. It says draw a picture, then find the surface area of the following. I want to find, oh, composite. This is, by the way, on the provincial, they're probably going to give you composite shapes. Oh, and sometimes instead of using numbers, they'll put letters, variables in place for lengths and widths and heights. Well, all they're asking is, can you generate the equation using their variables? Don't let it freak you out. I've even seen them do it sometimes with polynomials. They've said, oh, the side is x plus 3, and you're supposed to square it. Well, the answer will be x plus 3 all squared. FOIL it out. We'll talk about that. Anyways, I think you can try 3A, 3B. Okay. Now, from lesson 4. Shut up. You'll be fine. Lesson 4. I think you can try. Oh, they got chopped off a little bit. This got reformatted strangely. I think you can do L, because it looks like you have everything there that you need. It's 14 by 14, and the slant length is 9. On the next page, look up. This is L right here. Okay, so this one. Yes? Figured it out? It got reformatted when I moved to Office 2013. I didn't catch this when I hit print. Normally I'd do pretty good. I wanted to give you a composite shape, but that one got chopped off. So, you know what? You'll just do L for this one. Hand these both in stapled together, lesson 4 and 5. I'll count them as one big assignment. You got 15 minutes. You can work on the homework.